we'll be going over some sampling distribution information with some data in Excel and in R. So, in Excel here, I have some data, and in column 1 I have my whole population of data. In column B, or column 2, I have my first sample that I took of 100 of these observations, and in sample 2 in column C, I have another sample that I took of 1,000 of these observations. So, in order to calculate some of the sampling distribution information, we first always start off with calculating our mean. So we have the average of our whole population in this column here, and we'll calculate the average for our sample 1 using column B, and we use our formula to calculate the average for sample 2 in column C. And then we do the same for the standard deviation. Now, we're using standard deviation dot P in this column because this is our population, and we're doing the standard deviation of our population. So using this formula, we see the standard deviation of the population is about 8.15. To find the standard deviation of our sample, the formula changes slightly in Excel in that we use standarddev.s for sample for a sample, instead of standarddev.p for the population. And our standard deviation for the sample is right here. Using that same formula, we'll find our standard deviation for our second sample, our slightly larger sample. And now, what we need to do is find the standard error for our samples. So, what we do is we take the mean divided by the square root of the number of observations that we have, so 100 for sample 1. And with this formula that we're using, we find the standard error for sample 1 about 0.862. And we're going to do the same thing for sample 3. We're going to take the mean of sample 3 divided by the square root of 1,000, or the square root of the number of observations in our sample. And doing that, we find the standard error for sample 2. Now, what we can also do is find how many of our sample means fall between a high and a low interval in our data. And what we do for that is we take the mean minus the standard error. And that'll give us our low interval. And what we do is we take the mean plus the standard error to find our high interval. And for sample 1, we can say that 68% of our sample means will fall between 7.68 and 9.4. And we can do the same for sample 2. We take the sample mean minus the standard error, and we take the sample mean plus the standard error for our high interval. And we can say that 68% of our sample means for sample 2 will fall between 8.65 and 9.18. We can do the same for 95% of our sample means. For sample 1 and for sample 2. Now, R, of course, makes this all a whole lot easier as well. So, in R, we're going to load up our data. And you can see we have the same data set with the population, and from that population we're going to draw a couple of samples. So, in order to draw a sample in R, you use the command sample. And I'm going to store this sample in an object called sample1. We're going to sample from our data. The sample size is going to be 100, and we're not using replacement, meaning the same values can only be sampled once, and it won't sample the same values multiple times. So there's sample 1. And we can do the same thing for sample 2, except the size this time is going to be bigger. We're going to do a sample size of 1,000. And we can see in sample 1 we have 100 observations from the population. What this also does in R is pretty cool, is this ORIG ID column. You don't necessarily need it, but it may be useful for some larger data projects, is it'll tell you what row this number originally came from in the data. So 50 came from row 216 in our original data. And if we look at our original data, and we scroll to row 216, we see there's that 50 that we got in our sample. So, sometimes these values aren't stored numerically when you carry them over from Excel, and that's just an Excel to R error that sometimes happens. So what we do is we change the variable to just as numeric so that R knows that this is a number. And sometimes you'll get this little warning that'll pop up that'll say NA is introduced by coercion, but usually that isn't anything to worry about. We still have numeric values in all of our data, and now R recognizes that those values are actually numeric. And what we can do is find the average of sample 1, our population, and this NARM column just tells R to ignore anything in the data that's weird, missing, or has a value of NA. So if we run this, the mean of our first random sample is about 7.8. And we do the same thing for sample 2 and find the mean of sample 2. And for standard deviation in R, again, the command is just SD, which makes it very easy. And there's our standard deviation for sample 1 and our standard dev for sample 2.